Hi students. So today we'll see the economic order quantity. So economic order quantity model is a fundamental tool in inventory management that helps determine the optimal order quantity to minimize the total inventory cost. So it balances the trade-off between the ordering cost and holding cost. So we will see what is the trade-off between the ordering cost and holding cost. Then there are some assumptions in the EOQ model. So first we'll understand what is the EOQ models. So EOQ models is a ordering quantity. So suppose for annual demand is a 900 units. So we require the 900 units annually. Now we have to decide it how many times we can order this. Suppose economic order quantity is a 300. So we will put the three orders in a year. So because annual demand is a 900. So our economic order quantity is 300. So we will put the demand three times in a year. So likewise we have to solve the problem. So this is basic understanding of the EOQ model. So there are some assumption in EOQ model. First is that demand is a constant and known. So we must know the what is the demand per year for our organization. And then lead time. So that is lead time is actually time between the ordering and the receiving inventory is a constant. So we will get the inventory in time. So that lead time is a constant. Then no stock out occurs means when we ask for the inventory, there must be the availability of the inventory. So there is a no stock outs. And ordering and holding costs are constant. So ordering cost and holding cost. So ordering cost is nothing but the suppose we are ordering two times in a year. So that cost required for ordering this, that may be the shipment fee, or suppose we require the two books and we want to purchase that book from the 15 kilometer away. So the transportation cost, one when we are going to buy that book, we are taking the two books at a time. So transportation cost suppose 15 rupees. So 15 rupees is a cost, fixed cost for a transportation when we are buying the two products. Now what if we are doing that, we first go and then purchase the one book and again we go and purchase another book. So again that time that 15 plus 15 30 rupees is a cost. So likewise here ordering cost is a that cost. So cost required while ordering the product. And holding cost is nothing but the when we are purchasing the inventory, we have to store anywhere, and for that storing cost is nothing but the holding cost. So these are the key assumptions for a EOQ model. Then we will see the next part, that is what are the component of a EOQ model. So component first is the ordering cost. So cost associated with placing an order. So that is the ordering cost. We already seen that ordering cost means it is an administrative cost or shipping fees. Then holding cost. Now here C3 we have denoted by the C3. In some different book it is denoted by other nomenclature. So here we are considering C3 is the ordering cost. Then holding cost, that is a C1. So cost of storing the inventory, so in the warehouse or in the insurance for that inventory. So that cost is a holding cost. So that is a C1, or we can say the inventory carrying cost, that is denoted by the C1. Then demand, again every time you have to take the demand annual quantity of inventory required. So while we are taking demand for the calculation, we must consider it is a annually demand. So consider that is annually demand. Then holding cost, or we can say the purchase cost. So that is a per unit per annum. So here this cost is nothing but for one unit for 1 year, what is the cost. So that is nothing but the holding cost. And what is the ordering cost, or we can say the placement cost. So that is a single order cost. So for one order 15 rupees is required. So that is a single order cost. So cost is a ordering cost. Then holding cost, that is a cost required for per unit per annum, that is a holding cost. And demand, we are considering the annual demand. And order quantity, so number of units order each time, so that is the ordering quantity. So we must know that DQ, C1 and C3. From that we have to derive the formula for the same. Now this inventory model are concerned with the two decisions. So how much to order and when to order. So how much to order, that is nothing but the quantities. So suppose we require the 900 quantities. So we know that 900 quantities requirement. So how much to order we must know, and when to order. So this 900 quantity we can ask for each month, or from the 1 year we can ask for the three times. So that is we have to decide. So when to order. Then for the first decision, how much to order, there are two basic costs considered, namely. So that is the inventory carrying cost. Suppose at one time we have ordered the 900 quantities. Suppose then we have to increase. There is an increase in the inventory carrying cost. We have to carrying these inventory. So for that there is a maximum inventory cost, and there is another cost. Now while we are buying the 900 quantity one time, so ordering cost must be the one time. So we consider here 15 rupees cost like a previous example. So while ordering 900 quantity, we require only 15 cost. Suppose this 900 quantity we have divided into three parts, that is 300, 300 and 300. So here three times we require the cost. For first order 15 is a cost, and for second it again 15, and third again 15. We are taking for example like that. So inventory carrying cost and ordering cost, so these two costs are considered. So as the quantity order is increased, the inventory carrying cost increases. Here we have seen, so we have three times we have purchased, then again ordering cost is increases, while the ordering cost is decreases. So one time if we are order, then there is ordering cost is less. When we are ordering number of times, then ordering cost is more. So economic order quantity is calculated by balancing these two costs. So inventory carrying cost and ordering cost, we have to balance these two costs, and by balancing these two costs we have to find out the economic order quantity. So economic order quantity is that size of order which minimize total cost of carrying and cost of ordering. So for that minimum, where is the minimum total cost? So when there is an inventory carrying cost and ordering cost is the same, so there is a total minimum cost. We will see by the graph. So there is a trade-off between the these costs. So we will see that graph. So here it is a graph. So on x-axis here it is a quantity, and on y-axis there it is a cost. Okay, so quantity and cost. Now if you see this graph is for ordering cost. So ordering cost is decreasing here. So when there is a quantity is a maximum, so we are putting the 900 quantity one time, then there is a less ordering cost, we have considered suppose a 15. Okay, then holding cost. So holding cost is a proportional. When order quantity is increases, the holding cost is increases. Suppose we are having here 100 units, so that time there is a cost ordering cost associated with this inventory carrying is less. When we have put the 200, then it is increased 300, 400, 500 like that. Here we are taking suppose a 900, so there is a increase in a cost when the quantities increases. Now this is a trade-off between the ordering cost and holding cost. So what is the total cost? Where these two costs meet, so ordering cost and holding cost meet at this point. So at this point the cost is a minimum total cost, and at this point there is a economic, where what is a quantity, so we are considering this economic order quantity. Once again I will repeat. So it is a trade-off between the ordering cost and holding cost. Now we know what is ordering cost. We have to put the order. For that, what is the fee required, or what is the traveling cost, so these are the ordering cost. Then holding cost, if we are having a number of quantities, then we have to carry the inventory, the cost associated with that, that is a holding cost. And where these two points meet, so we can say there is a total cost. So here this cost is a minimum, total minimum cost, and where this quantity is known as a economic order quantity. Okay, so we have to derive the formula for a economic order quantity. So for that we have to compare the equation, that is the inventory carrying cost and ordering cost. So now we know that what is the inventory carrying cost. So the cost associated with the carrying, and ordering cost, the cost associated with the order. So first we will inventory carrying cost. So inventory carrying cost is nothing but the average inventory. So we can write down that is order quantity divided by 2. So that is average inventory into the storage cost. So storage cost associated with this. So inventory carrying cost, order quantity divided by 2. Why we have taken the order quantity divided by 2? Because it is a one half of a maximum order minus minimum order. So maximum order we can put the number of order required for the annual demand. Suppose here we have considered 900, and minimum order, that is a 0. We can put the 0 order. So 900 by 2, that is a 450. Similarly here order quantity divided by 2, so that is average quantity into the cost associated with the storage. So this is the inventory carrying cost is equal to ordering cost. So ordering cost is nothing but the annual demand. So annual demand divided by order quantity, into the ordering cost, or we can say the placement cost, ordering or placement cost. So this is a formula, ordering or placement cost. Now we know that what is order quantity. Order quantity is denoted by Q divided by 2 into, so what is the storage cost. We have seen that storage cost or holding cost we have given down, which is C1, is equal to annual demand. So annual demand is nothing but the total demand D divided by order quantity is Q into ordering cost or a placement cost, which is given by the C3. Now if we equate this equation, if we solve this equation, so here we will get here Q coming toward this side, so here it will become Q square is equal to D into C3 as it is here, that 2 coming toward this side multiplying by 2 and this C1 at the denominator. So here Q square, we get the Q square is equal to 2DC3 upon C1. Now if we take the square root of this, so we will get Q, that is economic order quantity, is nothing but under root of 2 into D into C3 divided by C1. So here we must know what is a D. D is a annual demand. So we are considering this is an annual demand. For calculation we have to take the annual demand. Then what is a C3? C3 is a ordering cost or placement cost, ordering cost, and C1 is nothing but the inventory carrying cost. So inventory carrying cost. So we must know this C3. What is C3? What is C1? What is D? D we are taking the annual demand. C3 is ordering cost for single order. Here we are taking for a single order. If we have put the 3 order, then and there also we have to take the cost associated with the single order. And here this is the inventory carrying cost for per product per annum. Suppose we have stored the one product for 1 year. So what is the cost associated with this? That is a C1. C3 ordering cost. D is annual demand into 2. So that is nothing but the Q, or we can say the economic order quantity. Okay. So this is the formula. Then we will see the problem associated with this. So an oil engine manufacturer purchase lubricant at the rate of 42 rupees per piece from a vendor. So we will understand first what is the problem. So they are purchasing the per piece 42 at a 42 rupees from the vendor. The requirement of these lubricant are 1800 per year. So we know here that is what is the demand. So demand is equal to 1800 pieces per, or quantity is a 1800 per year. What should be the ordering cost? What should be the ordering quantity per order if the cost per placement of an order is a 16 rupees? So cost per order is a 16 rupees. So cost per order, that is a, we know that is ordering cost is a 16 rupees per order. And then what is going, if the cost per placement of an order is a 16 and inventory carrying charges per rupee per year is a 20 paise. Okay, so here we have to calculate what is the C1. C1, we know what is the C1. C1 is a inventory carrying cost. So inventory carrying cost, so that is a per unit per annum, so now here inventory carrying, so for one product 42 rupees is a cost, and what is given here, so inventory carrying charges per rupee per year is a 20 paise. So here 42 rupees of a product, so for per product here it is a point 20 paise, or we can say the 20 paise, or we can say 0.20 rupees. So here we get the 42 into zero point 0.2, that is we can say 8.4 rupees. So 8.4 rupees is the inventory carrying cost for per product. Okay, once again I will repeat. So an oil engine manufacturer purchase lubricant at a rate of 42 rupees per piece. Per piece rupees is 42 rupees. Now we have to calculate the average inventory carrying cost for per product. And here the relation is given as inventory carrying charges per rupee per year is a 20 paise. For 1 rupee 20 paise. So for 42 rupees 8.4 paise. So that is the inventory carrying cost. So here we got the C1 value is 8.4. Now here we want to find out the economic order quantity. Now here we know the formula 2D into C3 divided by C1. So here we know all the values. 2 annual demand is 1800 pieces into C3 is a 16 divided by C1, that is a 8.4. If you solve this, you will get something that is 82 point something, so 82.8, or we can say the 83 quantity. So 83 product or 83 pieces, so that is a economic order quantity. Now this is the economic order quantity. So we have seen this first part, how to calculate the economic order quantity. Now if we want to decide how many times we can put the order, so this is 83 quantity we can put a one time. So how many times we are having in the 365 days in a year, so how many times we can put the order, so that we will see in the next slide. Okay, order quantity, that is formula for that is 2 into D into C3 divided by C1. Now we know that EOQ or denoted by it is a Q. Now optimum number of order for a year. So we know that what is the economic order quantity. So optimum number of orders. So optimum number of orders, that is denoted by NO. So here we have calculated the economic order quantity Q. So suppose 300 unit is the economic order quantity, but we have to decide the number of quantities, number of orders in a year, number of orders in a year. So here optimum number of quantity, how to calculate optimum number of quantity? So total demand D divided by economic order quantity. For example, we will take again 900 is our total demand per year, and we have calculated the 300 is the economic order quantity. So 900 divided by 300, so that is a 3 optimum number of orders we can place. So we must know optimum number of order, that is D by Q. Then optimum order interval. Now how to place the order? Optimum number of intervals, optimum number of interval, that is denoted by T naught. So here we know that is a 3 times we have to put the order. Then you may say that in 1 month we can put the 3 orders, so that is not possible. Okay, so how to calculate optimum number of interval, that is T naught. So there is formula is 365 days are available in a 1 year divided by number of orders. So from that we can calculate the optimum number of intervals. Then there is a average annual cost. So average annual cost, we can say average annual cost, that is denoted by TC. So that is given by 2 into C3 into D into C1. So you must know these formulas for solving the problems. So first we know economic order quantity. This is the formula for economic order quantity. Then optimum number of intervals, that is optimum number of orders, that is D by Q, and optimum number of interval, that is 360 divided by N naught. N naught is nothing but the optimum number of order, and average annual cost TC is equal to 2 into C3 into D into C1. So all cost, associated cost and number of quantity is into C1. So here from this we will solve the problem on this. So a manufacturer company, so here what is one manufacturer company purchased a 9,000 parts of a machine for its annual requirement. So here annual requirement is equal to 9,000. So annual requirement is a 9,000 of machine for its annual requirement. Ordering for a month uses at a time. Each part cost rupees 20. The ordering cost per order is rupees 15, and carrying charges are 15% of the average inventory per year. You have been assigned to suggest a more economical purchase policy for the company. What advice you offer and how much would it save the companies per year? So we will solve for this. For first we will calculate the economic order quantity, and then we will solve the remaining part. So for that, what is the requirement for economic order quantity? We must know the total demand is a 9,000. Then a cost of a part. So the each product having a cost, each part is having cost of 20 rupees, and a procurement cost, or we can say the ordering cost. Ordering cost per order is a 15 rupees. So we know that ordering cost is a C3. So 15 rupees is ordering cost. Now we have to calculate the C1. C1 is nothing but the inventory carrying cost. So how to calculate the inventory carrying cost? For one product, 20 rupees is the cost, and the relation between the carrying cost is given as 15% of the average inventory. So here 20 plus we have to calculate the 20 into 15%. So 15 divided by 100. If you solve this, you will get the 3 rupees per year. So 3 rupees is a per year. It's the inventory carrying cost, or we can say the C1, and C3 is a 15, and D is equal to 9,000. Now from this we will calculate the economic order quantity. So economic order quantity, we know that 2 into D into C3 divided by C1. So if you solve, if you put all the values, 2 into D, D value is a 9,000 into C3 value is a 15, and C1 value is a 3 rupees. If you solve these, you will get the 300 units. Okay, 300 units is the economic order quantity, or we know that is a Q. So here we got the Q value is a 300 units. Now what is asked in the problem. So here we have calculated 300 Q 300 unit. Now we will see what is asked in the problem. So for its annual requirement, ordering for a month uses at a time. So they are asking if they put the order at every month. So in a year there are 12 months. So they are saying that if they put the order in every month, means we have to put the 12 order. So that is one consideration. And other consideration, by our regular procedure or regular method, we have to find out the optimum number of order, and then we have to calculate the cost. So what is the difference in the cost, or which one is better? What advice you offer, and how much would it save the company per year? So for that we require optimum order interval. So we know that optimum order interval, I will solve here. So optimum order interval. So optimum order interval, or first we will see the optimum order, optimum number of order. Optimum number of order, that is a n naught, it is equal to d divided by q. So here d we know that is a 9,000 units, and q that is a 300. So here if we solve this, so we get the 30, optimum order 30. We can put the 30 orders, optimum order 30. And then next is a optimum order interval. Optimum order interval, that is t naught. T naught is equal to, we know that 365 divided by n naught. So here we get the 365 divided by n naught, we have calculated, that is a 30. So that value we know that 365 divided by 20. Now what is the average annual cost? So average annual cost formula, so TC is given 2 into D into C3 into C1. So if you put all the values, we know all the values. If you put all the values, so we will get the cost 900 rupees is the cost. And if you solve this, T naught is 360 divided by 30, so we will almost get it is a 122 days. So from in 122 days we will put the one order. Okay, so 900 is a total carrying cost. Now this is the first case. Here by this all the formulas we got the total average total cost is a rupees 900. So that is one case. Now what is asked in the problem for monthly? So if they are putting the monthly order, so monthly means there are 12 orders, and cost associated with the ordering is a 15 rupees. So total cost of ordering is a 180 rupees. So that is only ordering cost. So that is a ordering cost 180 rupees. Now lot size for every month. So we know that lot size, we are having a lot size d that is equal to 9,000, and every month divided by 12. So 9,000 divided by 12, we get the 750 quantities. So for per month 750 quantities. Now average inventory at a time, we know that is how to average inventory at a time. So average inventory at a time, so that is nothing but 1 divided by 2 into 750. So how this we have calculated? So 1/2 into maximum inventory minus minimum inventory. So maximum we can put 750 plus 0 divided by 2. So that is 750 divided by 2. We can say average inventory at a time, that is a 375. Then storage cost at a time. So we have to calculate the storage cost at a time. So storage cost at a time, so that is equal to 375 products into cost associated with this storage, that is a C1. So that is, we know that 375 and C1 we have calculated, that is 3 rupees. So if you calculate this, so it will give 1125. So 1125 rupees is a storage cost. Now what is the total annual cost? So total cost or total annual cost is nothing but storage cost plus order cost. So here storage cost is a 1125 and order cost is a 180. So this is a 1305 rupees. So 1305 rupees is a total cost when we are putting the order for every month. So this is a for every month. If we are putting the order every month, then total cost is a 1305. And by a regular procedure, if we put the order, so average cost is a 900 rupees. So instead of putting the order every month, we have to put this by the optimum order method or optimum cost method. So that is a 900 rupees is a cost. So here we can say there is a company should purchase 300 part at a time interval, 300 parts at a time interval. and rather than the ordering the for per month. So it will save our cost. So here 1305 minus 900, so that will 405 per year. So that will be the saving the cost. So likewise we have to solve the problem. So first find out the EOQ, economic order quantity, then what is the optimum order, then the optimum order intervals, then total cost. So this is by the standard method. And if they put the order every month, if putting the order every month, so we have to calculate the ordering cost. So there are 12 orders, so 180 is ordering cost. Then we have to calculate lot size. So 9,000 is total requirement divided by 12, so 750 is a one lot. Now for that lot, what is the inventory, average inventory? So 750 divided by 2, that is 375 is the average inventory. So we are calculating monthly. Now storage cost at a time, so 375 is the inventory, and cost associated with the storage is a 3 rupees, we have calculated previously. So here 1125 is the storage cost. So now what is the total cost? Total cost, storage cost plus the ordering cost. So 1125 plus 180, so 1305 is the total cost. So when we put the order monthly, and here we are putting the order when the by the number of optimum order. So it will save the 405 rupees. So this is the answer of the problem.